All right, so let's tackle example 2.7, which asks us to find a unit vector. All right, so we'll start off by letting the vector v have components 1, 2. And so let's find a unit vector with the same direction as v. So based on the rule that we had up above, this is pretty easy to do because we know that our unit vector u is equal to the scalar multiplication of 1 over the magnitude of our vector v times the vector v. So with that information then, what we're going to do is first compute the magnitude of v. And we know how to do that using Pythagorean theorem, right? So we're computing the magnitude of the vector with components 1, 2. And so using Pythagorean theorem, 1 squared plus 2 squared, we're taking the square root of that, and we get root 5. So my unit vector with the same direction as v, but magnitude 1, is 1 over root 5 times the vector v. So let's go ahead and do that multiplication. We're going to distribute the scalar into our components. All right, and so now we have a unit vector with the same direction as v and magnitude 1. So for part B of this example, let's find a vector w with the same direction as v, but we want w to have a magnitude of 7. All right, so we can still think about how scalar multiplication affects the magnitude of our vector. So if we go back to the work we did above with the normalization, right, we said, well, we know that the scalar multiplication into a vector adjust the magnitude of the vector by that scalar, by a factor of that scalar. So all we have to do then to figure out what w is to multiply 7 by our unit vector. So since this has a magnitude of 1, this tells us that the magnitude of w is equal to 7 times the magnitude of u, which is equal to 7 times 1, which is 7. So this is all we have to do. And since the direction of u is equal to the direction of v, we know that the direction of w is going to be the same as well. So we had to find that unit vector first. If we were asked to do this for any other example, our first absolute step would be to find the unit vector. That way we can get our direction. We're getting 7 times the vector 1 over root 5, comma 2 over root 5, which is 7 over root 5, comma 14 over root 5. All right, so let's take a look at the solution. I'm just going to make sure that we've got the right idea here. So to find the unit vector with the same direction as v, once again, they start off by just using Pythagorean theorem, getting that root 5 and dividing it into our vector v. Fantastic, we got the right answer. And then to find that vector w, we're just doing that scalar multiplication of 7 into our unit vector. So everything works out nicely. All right, so in the context of checkpoint 2.8, we're given a vector v with components 9, 2. We want to find a vector with magnitude 5 in the opposite direction of B. Interesting. So we'll have to think back to how we can determine opposite direction. All right, so pause here and give that one a shot on your own.